Okay, so this is the part 5 of the series of lectures in chapter number 7. In this part, I will be talking about various different characteristics of the duration, the concept which we have discussed in our last video. So let's talk about the rate shocks and duration estimate. In calculating duration using the formula we discussed in our last video, it is necessary to shock interest rates up and down by the same number of basis points to obtain the uh, V negative and V positive. In our illustration, if you remember, we used 20 basis points as an arbitrary value. But the question here is how large should be the shock? So how many basis points should be used to shock the rate? And whether the measure of this, the duration is sensitive to the amount of shock we are using. In this table, what I did is I have continued with the 4 bonds, the same bonds we have been using in this chapter. A 6% 5-year bond, 6% 20-year bond, 9% 5-year, and 9% 20-year bond. The initial yield is 6%, and here you can see 1 basis points, 10, 20, 50, 100, 150, and 200. What is done here is that the duration of the bond is calculated. Uh, uh, Duration of these 4 bonds is calculated on the basis of these different basis point assumptions. So if we use 1 basis point for this 6% 5-year bond, the duration is 4.27. At 10 basis points, it's 4.27, and at 200 basis points, it's 4.27. You can see that duration is not changing much, right? The same is true for this 9% 5-year bond. So 6% 5-year or 9% 5-year bond, 4.07 and 4.0. It's a slight little bit of change. But on the other hand, if you see the long-term bonds, this 6% 20-year and 9% 20-year bond, you can see that this goes from 11.56 to 11.79, and this 10.66 to 10.86. So although there is an impact of the basis points we use in calculating the duration on the value of the duration for the short-term bonds, for the long-term bonds, the effect is large. For the short-term bonds, it's a small effect, negligible effect. So this shows that their duration is not so sensitive towards the basis point assumptions we use. Another important concept of the duration is modified versus effective duration. The duration formula we have been using until now, the duration formula we are using is basically that is the modified duration, right? It can be effective duration. So what's the difference? The effective duration is so modified duration is the approximate percentage in bonds price for 100 basis point change in yield, assuming, this is very important, assuming that the bonds expected cash flows do not change when the yield changes. So modified duration is when we assume that the only effect on the value of the bond will be because of the changes in the discount rate, not in the cash flows. While on the other hand, effective duration assumes that the discounting at different interest rate and how the expected cash flow may change both affect the resulting duration. So when we take into account not only the changes in the discount rate, but also we use the V negative and V positive values based on the new cash flows, That is what when we are talking about the effective duration. So in short, effective duration is basically the concept which is very important for the bonds with embedded options. Remember, for the call options and for the put option bonds, the those options can really change the cash flows, not only the YTM but also the cash flows of those bonds. So, for example, a callable bond could have a modified duration of 5, but an effective duration of only 3, and that is purely because for a callable bonds, the change in discount rate or change in YTM can also impact the cash flows of the bond. So bond may be called early. Similarly, for a certain type of collateralized mortgage obligations, the modified duration could be 7 and effective duration can be 20, because those collateral mortgage obligations have prepayment option, right? So these things really can impact your duration values. So you have to keep in mind that what we are doing using is a modified duration. The effective duration will also have an impact on the cash flows of the bond. A related concept is about Macaulay duration and modified duration. The formula we have been using for calculation of duration is basically a shortcut formula. The duration formula, which is basically advanced by the Frederick Macaulay in 1938, is this one. That what you have to do is multiply present value of each cash flow with the time period in which it is occurring. This will be 0.5 for 6 months, 1, and so on and so forth. Add them up and then divide them with K into the price. K here is the number of period or payments per year. N is number of periods until maturity, which is K multiplied by number of years, and present value of cash flows. So this is the Macaulay duration. If we divide this Macaulay duration with the 1 plus yield divided by K, we get the modified duration, right? So Macaulay duration and modified duration are just another related concept of the duration. What I will suggest is go through the problems we have did in our last video and try to calculate the Macaulay duration and modified duration for the same bonds what we did, and also practice these questions of Macaulay and modified duration from the workbook, problems workbook I have shared with you guys. Okay. Interpretation of duration, just take a look at this at your convenience. Now let's talk about the portfolio duration. What we mean by portfolio duration. So basically, just like the various concepts for the portfolio we discussed, portfolio duration is just the weighted average of the individual durations. So for example, if I go to this worksheet, okay, let me switch to the Excel sheet. Just a moment. Okay, so here you can see I have a portfolio, and in this portfolio I have 3 different kind of bonds: 10% 5-year bond, 8% 15-year bond, and 40% 30-year bond. These are their prices, and this is the yield. So what I did is I have assumed the yield that all 3 bonds are yielding 10%, and then I calculated their prices. I will share this Excel sheet with you. You can find the formula beneath each of these cells, right? Okay. The par amount owned for each of these bonds is 4 million, 5 million, and 1 million. The market value based on the par amount invested and the prices is the 4 million. So how I calculated the market value is the par amount divided by 1000, the face value, and multiplied by the current price, right? So here you can see the amount invested divided by the par value 1000 multiplied by the current price, right? And these are the market values, and this is the duration given. So now what I will do is I will calculate the weights for each of these bonds. How to calculate weights? First add all of these market values. What I got is basically 9,609,963, and then I have divided each of the values, each of the market value with the total, each of the market value with the total market value, and I got the weights. So these are the weights. Then what I did is, to calculate portfolio duration, what we have to do is multiply weight with the duration, as I have shown you in the formula, weight into duration, right? And then sum them up. So what I did is multiply weight into duration for each of these, and then when I sum them up, so this is my portfolio duration. The portfolio duration for this portfolio, which contains these three bonds, is 6.47. This is the one way to calculate the portfolio duration. Let me show you another way to calculate this. Okay, so another way to calculate the duration is assuming, let's suppose, so this data is same as we had previously. So what now I am doing is I am assuming a change in value for 50 basis point yield. You have to make sure that in order to use this method, the yield on each of the bond in the portfolio should change by same percentage points. So I am considering 50 BPS change in the yield. So giving this 50 BPS percentage change, what I will be doing is using the duration formula, I will calculate the price. I will calculate the price of this each of the bonds. So so if duration increases by let's suppose if the what will be the change if the duration increases by 5 basis points. So this is the calculation. F2 duration minus 0.005 into 100 multiplied by E2 divided by 100. So this is the change we will get if the duration increases by. So I am not measuring the new price. I am just measuring the change because of this. Sorry, not increase, decrease in the duration, right? So for each of the bond, what I did is I measured the change in price if duration decreases by 50 basis points. And then I add these changes up. So these changes are 310,663. The method to calculate portfolio duration here is to divide this change in the value of the portfolio with original value of the portfolio. So for 50 basis points, this is G6 divided by E6 multiplied by 100 in terms of percentages, right? So what I got is 3.23 percentage change for 50 basis point decrease in the yield. Why? In order to, as the interpretation of duration is the percentage change in price for 100 basis point change. In order to calculate 100 basis point change, what I have to do is multiply 3.23 with 2, right? So I got portfolio duration. So it's exactly the same value which we calculated using the other formula, right? So that's all about the duration. In the next video, we will talk about the concept of convexity.